we can move on to our first speaker, who is Professor Sir Simon Lovestone. Professor Lovestone is a professor of translational neuroscience who I had the pleasure of working with at the University of Oxford. Prior to this, he was at King's College London, at the Institute of Psychiatry, and he really is one of the pioneers in dementia research, specifically around defining biomarkers of Alzheimer's disease, and also in looking at very large data sets of routinely collected clinical data, and really trying to tease out the any hints about, for example, potential medications that we may have missed, but for example, may have a positive impact on dementia and cognition. Simon has moved on to become the vice president in Janssen Pharmaceuticals, and is the head of neurodegeneration. So now he's overseeing a whole program, starting from the laboratory all the way to testing treatments in people. So I'm fantastically excited to have him speak to us. Simon, over to you.
Ivan, and hello everybody. It's really fantastic that Ivan and Heather and others have arranged this meeting, and it's even more fantastic that you're all part of Great Minds. I cannot thank you enough for your participation. It's only through studies or platforms such as Great Minds that will make progress on this disease, and we really do need to make progress. And spoiler alert, I'll tell you the takeaway from this little talk I'm about to give, and that is we are making great progress, and I have never been more optimistic than I am today that we will see a therapy that will slow and perhaps even prevent Alzheimer's disease. I think that is an achievable ambition. I'm speaking to you today in my role as an academic, a professor of translational neuroscience at the University of Oxford, although as Ivan says, I also now lead one of the world's largest pharmaceutical initiatives in Alzheimer's disease at J&J or Janssen, but I'm not speaking for Janssen today. I'm speaking for the University of Oxford. Now, I am, as I've just said, very optimistic. I'm really encouraged by the progress that we're making, but it's not enough. And I think, to use a football analogy, which is a game I sorely miss, as I'm sure some of you do too, in order to make progress, we need more shots on goal, we need to shoot earlier in the game, and we need to shoot more accurately. And I'm going to build on that idea of more shots on goal, shooting earlier, and shooting more accurately in this talk. But just a reminder, I know you know this, but honestly, I think it's worth reminding ourselves just how many people are affected by dementia and Alzheimer's disease in particular around the world. It's huge numbers today, and they're going to grow in a way that looks exponential, which is a word that you rarely heard only 3 months ago, but it is really increasing rapidly because of the aging population and the costs. And I apologize for using dollars rather than pounds here, but the costs to the economy are simply enormous. Now, we're living through a strange time, having a meeting like this where I'm speaking to you through Zoom and not being able to meet you in person afterwards and shake your hands. I'm very sorry about that, but we're all getting used to this. And we're living through very strange times with this appalling disease that's with us. But here's a fact that I think we need to hear more about, and it's a really sobering one. And that fact is that even today, at the very height of COVID-19, there are more people dying every month in the UK of Alzheimer's disease than there are of the virus. And actually, it's even worse than that, because of the people who are dying with the virus, a large number of them sadly have Alzheimer's disease, because COVID-19 is predominantly a disease of the elderly. And as we've heard only too tragically over the last few weeks, it's also a disease that has its most impact in nursing homes. And a very, very large proportion of people in nursing homes or other care situations have Alzheimer's disease. So for all of those reasons, Alzheimer's disease is going to be something that stays with us, taking away large numbers of our loved ones every month, every year, and every decade, and not just once in a lifetime until we do something about it. You're helping with that. And I'm going to try and tell you how we, on our side of the scientific bench, as it were, are trying to make progress, and I think really are making progress. So we're making progress with drug discovery, and in drug development and drug discovery, we tend to fit this into 4 parts. So it starts with discovery, where scientists ask what goes wrong in the disease and how might we correct it. That's usually done in the context of a university or something like that. And then you move from that to trying to find a drug that might work. And that's where pharmaceutical companies, small companies, but also including some initiatives like the one I set up at Oxford with my friend and colleague Chaz Bountra in academic context as well, try and find a chemical that might work, a drug that might work. And then you enter clinical studies. And that's where things like Great Minds and yourselves come to play. The start of those clinical studies, phase 1, asked the question, is the drug safe? And you've heard a lot about this in the last few weeks because of the COVID virus work, trying to develop a vaccine. You've heard about how those vaccines are going to be tested. And obviously it's a very difficult thing to do. That's phase 1, is the drug safe? Also in the latter half of phase 1, you're trying to find out how much of a drug might we use? And then comes a really critical phase. It's called phase 2. And is the concept right? So in a phase 2 study, what we're trying to do is to say, well, now we have a chemical, it works in the laboratory, we know it's safe, we know how much of it we'll use, but in people, if we do what this drug does it look like we would be having an effect that would be useful for Alzheimer's disease? So it might be an effect on the brain, which we can measure through the kinds of work that John O'Brien does with brain scanning, or it might be measuring what we call a biomarker or test, and I'll come back to that. But it's essentially asking, is the concept of this drug right? And then comes the most important phase. That is phase 3, which is asking the question, which is at the end of the day, the only important question, and that is, does it work? And we measure how a drug works by measuring cognition, this kind of tests you're having in Great Minds, but also whether people who don't have the disease end up getting the disease or whether they're protected from it. So that's drug development, and it is a fabulously costly business. And you only have to look at these costs and you realize how difficult it is, even for very large companies like the one I work with now, but also countries like the UK that have put a lot of money into research for Alzheimer's disease. You realize how all of that investment isn't anything like enough. The cost of the Alzheimer's disease development pipeline that I've just shown you is in the region of $5 to $7 billion for every single drug. And given that every single drug we've tried up to now has failed, this is a very expensive business. And I suppose if I have one worry, it is that if we don't make progress really soon, countries, companies, philanthropic investors will start to say, maybe we can't do this. Maybe it's just too difficult, too expensive for us. We're not there yet. We are making progress. And I think we're going to see a lot of progress over the next 5 years or so. But this is a very, very expensive business. The first progress that has been made over the now nearly 30 years I've spent working on this disease is we understand a huge amount about the process of Alzheimer's disease. So the patient that you see there, or the woman that you see there, her name was Augusta Dieter, and she was in a way the first person with Alzheimer's disease because she was the patient who was a doctor working in Germany at the turn of the 19th and 20th centuries, and he described this condition that affected her, and a colleague of his, Emil Kraepelin, in fact, who was the founding father of psychiatry, he decided to call this disorder, which was a new disorder to science at the time, Alzheimer's disease. When Augusta Dieter died, Alzheimer got to have a look at her brain. So this was a really new technology. It's sort of the white heat of technology at the time, was being able to do a post-mortem and actually look in the microscope at what was happening in brain tissue. And he saw these two things. Now, what you're looking at there, those grey pictures, they actually come from a patient of mine that I looked after right at the beginning of my career. So this would have been in about 1990 now. And his family, when he died, allowed me to use these pictures, especially for training and education and communication. And I've used them many times, and they've been used by others. And every time I show them, I think about him, because he had this disease that Alzheimer saw. The two lesions, it's a technical talk, the two changes in the brain that you see there, on the left-hand side, the round thing, that's a plaque, and it's formed from a protein called amyloid. And that leads on to these little squiggly things that Alzheimer described, and they're called tangles, neurofibrillary tangles. And they destroy brain cells, and it's that gives rise to Alzheimer's disease. Now, when I first started, I went to join the laboratory of my mentor called Brian Anderton, and he and a few other scientists had just discovered the protein that caused those neurofibrillary tangles. It's a protein called tau. And Brian Anderton, set me the task, and others, to say, see if you can find out how this sequence of events occurs. Over the years, the 30 years or since then, hundreds, probably thousands of scientists around the world have contributed to this understanding. We now really understand it very well indeed. We understand many of the genes that affect Alzheimer's disease. They don't cause it, they just increase your risks a bit. We also understand some of the environmental factors like diabetes and head injury that increase your risk. Again, they don't cause it, they just increase your risk. We know that these increase your risk of getting plaques, they increase your risk of getting tangles, and that's what gives you Alzheimer's disease, dementia. Once we understand this, that's the first phase of the discovery program or development program I just showed you. We can now set about finding drugs for this condition. And look, this was in 2019, a large number of drugs. Each one of these, the words don't really matter, but these are the names of the drugs. Each one of these drugs was in a clinical trial last year. The way this diagram goes, in the outer circle, those are the drugs that are in the first phase that I told you about, phase 1. The drugs that are in the middle circle, those are in phase 2. And the drugs that are right in the bullseye, those are phase 3 drugs. And in the third of the pie that's facing upwards, these are drugs that are trying to affect that biology that I've just shown you. And they do so through things that you may have read about actually in relation to COVID, called passive and active immunization. That is giving somebody else's antibody or an antibody you've made, or giving a vaccine. The drugs in the purple third of the pie, these are conventional chemicals or drugs, and the others are more complicated combination type approaches. So many different drugs in development. That is great news. Bad news, every one of those drugs in the middle bullseye that has been tested up until now has failed. Every one of those failures is a $5 to $6 billion failure. Look at the money that is being spent. So are we getting better? Well, I think that we are getting much better at doing this. One of the problems that we've had up until now, and this is my personal opinion now, one of the problems we've had up until now is we haven't had that many shots on goal. So most of those drugs that I've just shown you were just trying to do one thing. They were trying to prevent the formation of the amyloid plaque that I showed you that was described by Alzheimer in Augusta Dieter's brain. So even in 2018, over half of all drugs in late phase were targeting just one disease process. That's not good enough. given how difficult it is to do this, we need to try and do more different things. So let's have a look at what happened later. What we also know, as well as the plaques and the tangles, we know that in Alzheimer's disease, there are other things that happen. We know that the brain has inflammation, it's inflamed. We know that proteins are clumping together, not just amyloid, not just tau, but many other proteins as well. That suggests there's a general problem in something called proteostasis. These cells that you're looking at there, the neurons, the brain cells, they connect to each other. And the point where they connect or talk to each other is called the synapse. And in Alzheimer's disease, we know those synapses retract. The cells become isolated. Another word we've become unfortunately used to using about ourselves. And when things get isolated, they don't talk to each other. You know, that doesn't work so well, and your thinking becomes disrupted. And we know that synaptic dysfunction is a function of Alzheimer's disease. So why don't we develop not just drugs against amyloid, but perhaps to these other processes in Alzheimer's disease? Well, the answer to that question is we are. Let's look at what happens just 1 year later. In 2018, half of all drugs are being developed against amyloid. In 2019, only a third of all drugs are being developed against amyloid. In 2018, only 4% of drugs are being developed against tau. In 2019, double that, 8% of drugs are being developed against tau, and so on. So just what you're seeing here, a movement, and it started many years ago, but every year we have more and more diverse targets. That reduces the risk. It increases the chance of us finding one that will work. We also, though, need not just to shoot more often, become more diverse in our drug development, but shoot earlier. So this is a general picture of what we think happens in Alzheimer's disease. The solid bar is your thinking ability, your cognitive function as you get older. As people of my age know, your cognitive function gets slightly worse, not very much worse, I hope, but just slightly worse as you get older. But in Alzheimer's disease, it gets very much worse and people enter dementia. But before that, there's a phase called mild cognitive impairment. But actually, the disease starts even before that in a preclinical phase. If we could do our clinical trials earlier in mild cognitive impairment, or perhaps even in preclinical phase, common sense tells you you're more likely to get a drug that has an effect. Problem is, it's very hard to do those clinical trials. Sometimes those trials are called secondary prevention. So what this means is that if I take a drug before I have symptoms, but when I have the disease in my brain, I just don't know it, and if that drug works completely, then I'll never develop symptoms. And as far as I'm concerned, I've been prevented from getting the disease. And that is increasingly what we're trying to do in our clinical trials. But to do that, we need to know who in great minds is already beginning to get the disease process, maybe 10 years before they have any symptoms at all. And in that, we need to shoot more accurately. We need to be able to diagnose people better and more earlier in the condition. We need to shoot more accurately at the disease. And we now have biomarkers that can detect plaque or amyloid pathology, as well as tangle or tau pathology before people have symptoms. We can do that through a kind of brain scan called PET imaging, or we can do that through a chemical measure in the spinal fluid with a needle into your spine, much like women have, or very similar to women have, for example, an epidural when they're giving birth. Now, both a PET scan and a spinal tap test, they are a bit invasive. They're uncomfortable. They're not painful, but they're uncomfortable to have. You have to go into a hospital to have them done. And increasingly, we've been trying to find a blood test. And one of the biggest advances in the last 18 months or so, I suppose, is it's now very apparent that we will be able to soon have a blood test that is quite good at measuring these pathological processes. Not as good as a brain scan or a lumbar puncture, won't do away without those, but it might be a step in the diagnostic process. But we also want a different kind of test, and that is a test, how can I as a researcher do those proof of concept phase 2 trials? If you remember, I said those are the trials where I don't need to know whether the drug is really working, is it effective? I just give me an idea. Let me do a shorter trial, expose less people to a drug, just to give me an idea, is this likely to work? And for that, we need a progression marker, that is a test that would let me have an idea whether a drug is likely to work or not. And up until now, we haven't had those. Now, I think some of you might be volunteering for the deep and frequent phenotyping study, which is a study that is led by Vanessa Raymond, who we'll hear from later. And what this study is trying to do is to find some measure, might be a brain scan, might be a blood measure, it might be measures of your eyes, a retinal scan, it might be using a phone so that you can measure people's movements. It could be all sorts of different measures. And we're going to try all of these in a short period to see whether any of them act as a progression markers that would allow us to do more, faster, more effective proof of concept phase 2 trials. So I think I'm probably nearly out of time. Let me just say a bit quicker than I'd otherwise intended, where I personally think the most optimistic or the most promising therapeutic developments are. And this is on the tau biology. It's what I've been working on for 30 years, along with lots of other people, obviously, around the world. So of course, I'm going to think that's the case. Now here, I can't resist showing you this. In the top of these, you see a maggot. It's a fruit fly maggot. That's a normal maggot. The one on the bottom, you see a maggot that we've tried to make have some of the characteristics of this tau pathology or Alzheimer's disease. And you can see that maggot isn't doing very well. It's not moving very quickly. And if you look on the left-hand side, you can see the clumps, which are a bit like the clumps that we think happen in Alzheimer's disease. Now, in contrast to the amyloid pathologies, we know that tau pathology results in dysfunction of brain cells. We've got lots of evidence from models like this, animal models, as well as from people, that if you target tau, you might have a therapy for Alzheimer's disease. We also know that the more tau pathology you have in your brain, the worse your clinical symptoms. And most interesting of all, we know tau pathology crosses from one brain cell to another. So there's been an explosion of tau-based therapeutics or drugs. There have been small molecules, chemicals that affect tau processes. There have been larger molecules, including these antibodies that you hear a lot about at the moment. And the thing that I find most exciting is the potential to actually vaccinate people against tau pathology. All of these are in development, including in the company that I work for, but also in most other companies and in lots of academic laboratories around the world. I am really hopeful that one of these will work. But if they don't, we also have drugs that are being developed against inflammation, against clumping of other proteins, and drugs that are there to support the potential for synapses to work nicely together. And it might be that we need to combine these approaches. And in cancer, nobody with cancer gets one drug any longer. They get a combination or a cocktail of drugs. I think in the future, that's what Alzheimer's therapy will look like. So a last word, it's not just Alzheimer's disease therapy that we're talking about here. These processes that we're exploring in neurodegenerative diseases also affect multiple sclerosis, Parkinson's disease, frontotemporal dementia, and lots of other diseases. Did I say motor neurone disease? Motor neurone disease as well. And there's an overlap between these conditions. And I'm really hopeful that we'll see progress, not just in Alzheimer's disease, but in many of these other disorders as well. So to finish off, I've tried to show you how we get more shots on goal by diversification of drug development, how we're trying to go earlier in our clinical development to shoot at those goals earlier, and we're trying to make our clinical trials more effective with biomarkers. Is there end of Alzheimer's disease in sight? Well, you know, this development program that I talked to you about from discovery to phase 3 is typically 10 to 15 years in this field. We're some way along, but currently most of the drugs that I'm most optimistic about are still only in phase 2. So we're looking at probably at least another 5 to 10 years before many of these trials even finish. It's going to take we're in this for the long haul. It's going to take a long time, but I do think an end is in sight, and I think we're making huge progress. And if you're interested in reading a little bit more detail about the talk I've just given, I think this journal article that I wrote earlier this year is available. It's free, and you can download it if it isn't being made available. And it's not, I hope it's not too technical. So with that, I want to thank you and apologize, Ivan, for going somewhat over.
Thank you very much, Simon. It's always a pleasure to hear you speak. We have a bit of time for questions. We have a couple that have come in. The first question, Simon, is whether, looking to the future with all of the projections about the numbers who will develop Alzheimer's disease, do we have an idea of what percentage of the population will end up having Alzheimer's disease?
Yes, to some degree, we know that already. It's of people aged over 65, it's about 5% who have active dementia. And of people over the age of 80 to 85, it's over 20% of people who have active dementia. The reality is it's even more than that, because a large number of elderly people have the disease in their brains. And of course, some will pass away through some other condition before anybody ever knows they've got dementia. It's a very high percentage of the population.
Yeah. And Jeff Richards is asking about the link to vascular dementia. So he's saying, you know, for example, the British Heart Foundation is carrying out research on vascular dementia. How good are we with linking in with the vascular research that is ongoing?
It's a really good question, Jeff. I think that we've gone through, it is a bit like a pendulum, really. We've gone through a process where we've become ever more specific in our diagnosis. So people get a diagnosis of Alzheimer's disease or vascular dementia or one of the other forms of dementia. The truth is it's more complicated than that. And the fact, I think, is that most people have a combination of different pathological processes in their brain. And many, many people who have a diagnosis of Alzheimer's disease also have some vascular dementia evidence when they pass away. And that's even more true in the other direction. The vast majority, if not everybody with vascular dementia, has some signs of Alzheimer's as well. So I think our understanding is becoming more sophisticated, and some of the research is becoming really interesting, thinking about how we can combine approaches to both the vascular damage that happens in the brain as well as the Alzheimer's disease damage that happens in the brain. And I think this relates to my last point, that I expect at some point we'll be talking about combination therapies. I hope we will anyway, including for vascular dementia.
Okay. Michael Ben is asking a question that is quite close to the work that we're doing. He's asking, how will people in the pre-symptomatic stage of disease be identified for early intervention, and will this be feasible in a system that's struggling for funding? Where will that fit in the whole healthcare model?
It's a really good question. And Ivan, you might want to, as the lead for Great Minds Study, you might want to contribute to this. I think it's really important, Michael, to say at the moment, we're only envisaging doing this in the context of research. So we're only considering doing it for people who want to volunteer for clinical studies or in a not completely anonymous studies, because right now there is no clinical reason, there's no health reason for knowing that you have a disease in your brain that is not causing you any symptoms when there are no treatments. In a research context, though, I'm hoping that we will have ever easier to use tests or biomarkers that will be employed in studies like Great Minds so that people who want to volunteer can volunteer for the right study because their biomarkers show them that they've got the relevant pathology. But we do have to get better in clinical trials. Here's a terrible statistic. In 2 of the biggest trials that have ever been done in early stage Alzheimer's disease, these trials alone cost huge amounts of money. In 2 of these studies, 20% of the people that gave all of their time and took the drug didn't actually have Alzheimer's disease. Honestly, we can't go on like that. You can't run research like that. So doing these preclinical or early diagnostic tests is really useful for research. Right now, not useful in the clinic. Your implication, though, is let me extend your question a bit. Once we have a treatment, how will we do this in a health service that is coming under stress and strain? It's a really important question. And I think we have to not just ask, but we have to demand that this is done when we have treatments that are effective. And I would remind politicians and the people who fund the NHS that Alzheimer's disease costs 1% of the world's GDP every single year. So Alzheimer's disease costs huge amounts of money. The biggest cost is to individuals themselves and to their loved ones, but there's a real financial cost as well. And if we had an effective treatment, we might be able to reduce that financial cost.
And in the interest of time, one last question. I guess it goes in the other direction. So Helen is sort of sharing some personal experiences about bringing her mother to the GP 3 or 4 years ago with concerns about cognition, but then not being told that it's severe enough. And now she has dementia. So in a sense, there is this other group of people who are sort of in between, that they're not ill enough, and yet, there's clearly something wrong. What do you say to that group of people? How is the healthcare system looking after them? What is your impression?
Yes, I mean, I share your experience from my own family, and I know how frustrating it is and how angry it can make you, and then how sad it is when you realize years later you were right all along. And I do think it is really important that people get a diagnosis at the point they ask for a diagnosis. I don't think it's sensible to go screening populations, meaning screening people who haven't asked for a diagnosis. But when you or your loved one is worried about memory problems, I think you should go to a doctor and you should get effectively tested. And I think that family doctors, GPs, should be capable of doing good cognitive testing and then refer on for diagnosis in a specialist clinic. Some researchers at John O'Brien's University some years ago showed that half of all the people with actual dementia are not recognized as having that in the community. That was some years ago. My sense is that's changing, and that GPs are now much better advised and educated, and the whole community is more sensitive to Alzheimer's disease. So I think that is getting better. But I absolutely agree with you. When you're worried about somebody with dementia, you should be able to take them to their doctor, and they should be approached sensitively, but a memory test should be done and it should be followed up, and they should go to a specialist clinic. There's no reason today for that not to happen.